The universe holds secrets that defy everything we think we know. We are about to journey through 30 cosmic oddities, strange and bizarre phenomena that will completely reshape your understanding of reality. You will discover ghostly galaxies with almost no dark matter and stars that somehow survived their own violent deaths. By the end, you will possess a new perspective on the sheer, wonderful weirdness of the cosmos. What is pulling thousands of galaxies, including our own, towards a mysterious, hidden point in space? How can a star possibly be older than the universe itself? These are just a glimpse of the enigmas waiting for us. What is the most baffling space mystery you have ever heard of? There is a structure in space that looks as if it were drawn with a ruler. The Red Rectangle Nebula is not a hazy cloud of gas. It is a near-perfect X-shape, glowing with a deep ruby red light and crisscrossed with what seem to be the rungs of a cosmic ladder. This is not the work of an alien artist, but the final, beautiful death throes of a star system. At its heart, two stars orbit one another in a tight dance. As one star nears the end of its life, it expels its outer layers into space. But instead of forming a simple sphere, the gravitational push and pull between the two stars squeezes this ejected material into two opposing cones, creating that stark X shape we see from Earth. The mysterious ladder rungs are thought to be periodic outbursts from the central stars, ejecting rings of dust and gas that we see edge on. Yet the sheer geometric precision of it all remains a profound puzzle. How can such perfect symmetry emerge from the violent, chaotic process of stellar death? Scientists continue to debate the exact mechanics, making this celestial artwork one of the most strangely beautiful and unexplained structures in our galaxy. The geometry of the red rectangle seems almost deliberate, but it is not alone in its perfection. Drifting through the void more than 600 million light-years away is a galaxy that appears as a flawless cosmic bullseye. Known as Hoag's object, this ring galaxy presents a sight so pristine it feels impossible. A nearly perfect circle of brilliant young blue stars encircles a dense golden core of ancient suns. Between them lies a profound and seemingly empty gap, a dark chasm that cleanly separates the two stellar populations. This is not how most galaxies are supposed to look. Typically, ring galaxies form when a smaller galaxy punches straight through the center of a larger one. The gravitational shockwave triggers a wave of star formation that ripples outward, creating a ring. But Hoag's object shows no evidence of such a violent collision. There are no tidal tails of scattered stars, no remnant of a galactic intruder. The central core is perfectly round and undisturbed, floating serenely within its stellar halo. The greatest enigma is the complete absence of a connecting bar, a bridge of stars that, in other ring galaxies, typically links the core to the outer disk. How did this celestial target form with such perfect isolation? Some theories suggest a past instability, a resonance that redistributed the galaxy's material into these two distinct zones. Yet the mechanism remains one of cosmology's most elegant puzzles, a solitary ring of brilliant blue fire that defies every conventional story of galactic birth and evolution. What other serene and beautiful mysteries are waiting, hidden in the depths of space? From the perfect geometry of a single galaxy, we now shift our gaze to a staggering emptiness on a scale that is almost impossible to comprehend. In the constellation of Boötes, there exists a region of space so vast and so barren it has earned the name the Great Nothing. The Boötes Void is a spherical chasm of near-nothingness, spanning an incredible 330 million light-years across. To put that into perspective, if our Milky Way were at its center, we would have had no knowledge of any other galaxies until the 1970s. In a universe that seems overwhelmingly crowded with stars and galaxies, this void is a shocking desert. Where astronomers would expect to find thousands of galaxies, they have instead found only a few dozen, scattered like lonely islands in an endless, dark ocean. The very existence of such a void challenges our fundamental models of the cosmos. How could the Big Bang, which presumably spread matter evenly, leave behind a vacuum of this magnitude? One leading theory points to the echoes of cosmic inflation, the universe's violent expansion in its first moments. Tiny density fluctuations from that primordial era may have been amplified over billions of years, creating vast bubbles of matter and corresponding voids of emptiness as space itself stretched. But the Boötes Void is so disproportionately large that some scientists wonder if it is not a void at all, but a sign of something else entirely. Could it be evidence of a cosmic structure so immense that its true shape and emptiness are only just beginning to reveal themselves? This great nothing is not merely an absence, it is a profound question mark, forcing us to reconsider the very fabric of the universe and what other immense, empty structures might be lurking in the dark. That immense void in Boötes is a monument to cosmic absence, but there is another region of space defined by an overwhelming presence, a force so powerful it commands the motion of our entire galaxy. Lying in the direction of the Centaurus constellation, a gravitational behemoth known as the Great Attractor is pulling the Milky Way, along with thousands of other galaxies, toward it at a staggering speed of over 14 million miles per hour. We are caught in a cosmic river flowing toward a destination we cannot clearly see. The core of this mystery is frustratingly hidden from our view, obscured by the zone of avoidance. This is the thick, dusty plain of our own galaxy, a band of interstellar debris that blocks our sight like a mountain range standing between us and a distant city. For decades, the true nature of the Great Attractor was a complete enigma, a shadowy force we could feel but not observe. What could possibly possess enough mass to exert such a titanic pull? Early theories suggested it was a massive supercluster of galaxies, a congregation of thousands of island universes whose combined gravity was creating this immense flow. But as our observational tools, particularly X-ray and radio telescopes that can peer through the dust, have improved, the picture has grown even more complex. We now see that the Great Attractor itself is merely a waypoint, a local concentration of mass that is also being pulled toward something far grander and more distant, a structure known as the Shapley supercluster. This reveals a cosmic hierarchy of pulls within pulls, a gravitational tapestry where even the Great Attractors are themselves being attracted. The question then becomes not just what the Great Attractor is, but what lies beyond it, pulling the puller in an endless chain of cosmic influence. While the Great Attractor pulls our entire galaxy, another star far closer to home began behaving in a way that seemed to defy all logic. It flickered. Not with the gentle, rhythmic pulse of a planet passing in front of it, but with wild, chaotic, and dramatic drops in its light. This is Tabby's star, officially catalogued as KIC 8462852, and its bizarre behavior sparked one of the biggest modern debates in astronomy. The Kepler Space Telescope, designed to hunt for planets by spotting the tiny, periodic shadows they cast, found something utterly different here. Instead of small, predictable dips every few days or weeks, Kepler observed staggering drops in the star's brightness. At times, the light from Tabby's star would plummet by more than 20%, an amount so immense it would require an object many times larger than the star itself to block it. Then, just as suddenly, the light would return. These were not clean, symmetrical dips, but jagged, irregular patterns that looked nothing like a planet. Even more baffling was the long-term data. Over the 4 years of Kepler's primary mission, the overall brightness of Tabby's star was also fading, as if something was gradually consuming its light. When the data became public, the theories exploded. The most cautious explanation pointed to a giant, fragmented swarm of comets, their dust and ice blocking the light in irregular ways. But the scale required was almost unbelievable. This led to the more sensational yet irresistible hypothesis. Could we be witnessing the construction of an alien megastructure, a vast array of solar collectors known as a Dyson sphere being built around the star? The idea captured the public imagination, but scientists kept searching for a natural cause. They have proposed everything from the aftereffects of a planetary collision to intrinsic properties of the star itself, like immense magnetic storms or clouds of dust from its own asteroid belt. Yet, years of intense observation with the world's most powerful telescopes have failed to provide a definitive answer. Each new dimming event seems to add another layer of mystery. Tabby's star remains an unresolved enigma, a cosmic beacon of unpredictability that challenges our assumptions and reminds us that sometimes the most compelling mysteries are not in the distant voids, but in the familiar patterns of a single flickering sun. The flickering of Tabby's star invites speculation about intelligence, but decades earlier, a single, silent burst from the cosmos delivered a message so clear and startling it was literally written in the margins of science. On a quiet August night in 1977, the Big Ear radio telescope at Ohio State University was scanning the sky when it recorded a signal that defied all natural explanation. For 72 seconds, a powerful, focused burst of radio waves erupted from the direction of the constellation Sagittarius. It was a narrowband signal, concentrated on one specific frequency, just what scientists predicted an artificial interstellar transmission would look like. When astronomer Jerry Amon reviewed the computer printout days later, he was so stunned by the data that he circled the alphanumeric sequence and scribbled a single, emphatic word in the margin: "Wow." That one word named a mystery that has endured for nearly half a century. The wow signal was not a repeating pattern or a message. It was a transient shout in the dark, a signal that appeared, reached an incredible intensity, and then vanished completely. Its characteristics pointed directly to a source beyond Earth. It was not a passing satellite or a random burst from a star. The signal's frequency was protected, a quiet channel where terrestrial broadcasts are forbidden, making a human origin highly unlikely. The most compelling and frustrating aspect of the WOW signal is that it was never heard again. Decades of follow-up observations using far more sensitive equipment have scanned the same patch of sky for any hint of a repeat performance. They have found only silence. Was it a one-time transmission from a distant civilization, a cosmic flare that we happened to catch for one brief moment? Could it have been a bizarre, previously unknown natural phenomenon that mimicked an artificial signal with perfect precision? Without a second detection, the WOW signal remains frozen in time, a tantalizing piece of data that is both the most famous and most enigmatic event in the history of the search for extraterrestrial intelligence. It stands as a monument to a fundamental question: are we listening closely enough? And if a call comes, will we be ready to understand it? That signal from the depths of space was a transient mystery, but a more persistent one is said to be orbiting much closer to home, watching us from the darkness above. The legend of the Black Knight satellite tells of an ancient alien probe that has circled our planet for thousands of years. Its story begins not with a telescope, but with the pioneering radio experiments of Nikola Tesla in the late 19th century. While testing his wireless transmission systems, Tesla reported receiving strange, repeating signals that he believed could be an attempt at communication from another world. Decades later, in the 1960s, both American and Soviet space tracking stations reported detecting a mysterious, dark object in Earth orbit. It was in an unusual polar orbit, a path that seemed odd for the time. Newspapers ran stories about an unidentified satellite of unknown origin, and the legend of the Black Knight was born. Proponents of the theory point to a photograph from the 1998 Space Shuttle Endeavour mission that appears to show a strange, dark object against the curvature of the Earth, a silent sentinel that should not be there. They weave a compelling narrative of an alien artifact, perhaps tens of thousands of years old, sent to observe human civilization. Yet for every piece of enigmatic evidence, there is a grounded scientific explanation. The signals Tesla heard are now widely attributed to naturally occurring radio emissions from pulsars or other cosmic phenomena that were not yet understood. The anomalous object tracked in the 1960s was likely the remains of a Discoverer satellite, a secret American reconnaissance program whose orbital data was not publicly available. And that iconic photograph from the space shuttle, it almost certainly shows a thermal blanket that had been accidentally lost during a spacewalk, a piece of human-made debris tumbling silently alongside the orbiter. The true oddity of the Black Knight is not its alien origin, but its powerful grip on our imagination. It persists as a cultural artifact, a testament to our desire to find patterns and purpose in the unknown. It lives on in films, books, and across the internet, a modern myth born from fragments of misunderstood science and genuine human curiosity. Why does this particular story resonate so deeply? Perhaps because it suggests that we are not alone, and that the proof has been floating just overhead all along, a secret waiting to be uncovered in the starry sky. While the legend of the Black Knight orbits our world, a far more authentic and ancient relic drifts in the depths of space, a galaxy that simply stopped living. NGC 1277 is not merely old, it is a fossil, a celestial museum piece that appears to have halted its own evolution 10 billion years ago. In a universe defined by constant change, where stars are born and die in brilliant cycles, this galaxy is frozen in time. Most galaxies, including our own Milky Way, are vibrant and diverse cities of stars, with ancient red suns in their cores and lively, young blue stars sparkling in their spiral arms. But NGC 1277 is a monolithic, red and dead galaxy. It is almost entirely composed of old, red stars that formed in a single, furious burst at the dawn of time. There are no nurseries of glowing gas, no infant blue stars being born. Its star-making machinery shut down long ago, and it has been drifting in a state of suspended animation for billions of years. How does a galaxy simply stop? The leading theory paints a picture of a tragic and isolated youth. Billions of years ago, when the universe was denser and more chaotic, NGC 1277 may have been a voracious cannibal, rapidly devouring its smaller galactic neighbors and using their gas to fuel an immense wave of star formation. But this feast may have been its downfall. The process could have been so violent and rapid that it used up all its available star-forming gas in one colossal burst. Alternatively, as it fell into the dense core of its galaxy cluster, vast intergalactic winds may have ripped away its remaining gas reserves, starving it of the raw materials needed to create new suns. Whatever the cause, the result is a galaxy that has been asleep since the universe was in its infancy, a cosmic ghost that challenges our understanding of how these vast islands of stars are meant to grow and change over time. Frozen in time, that ancient galaxy is a monument to cosmic stillness, but some worlds are forged in the very heart of chaos. Orbiting perilously close to its sun lies a planet that seems torn from the pages of science fiction, a world of unimaginable wealth and hellish conditions. 55 Cancri is a super-Earth, a giant rocky planet about twice the size of our own, but the similarities end there. It is a world believed to be composed largely of carbon, with a significant portion of that carbon crushed into crystalline form. This is the Diamond Planet, a glittering jewel of the cosmos. Its orbit is so tight that a full year lasts only 18 hours. The planet is likely tidally locked, meaning one side permanently faces its star, broiling under an eternal, scorching day, while the other is plunged in endless night. Surface temperatures on the day side soar to over 4,000 degrees Fahrenheit, hot enough to melt rock and vaporize most metals. Imagine a landscape not of solid ground, but of a seething, global lava ocean, shimmering under the intense glare of a nearby star. How can we possibly know what a distant planet is made of? Astronomers use a technique called spectroscopy. As the planet passes in front of its star, a tiny fraction of the star's light filters through the planet's atmosphere if it has one. By analyzing the specific colors of light that are absorbed, scientists can detect the chemical fingerprints of elements like carbon. The data from 55 Cancri E points to an atmosphere rich in hydrogen and helium, but a core dominated by carbon. Under the immense pressures and temperatures within the planet, that carbon would be compressed into diamond, potentially forming a layer hundreds of miles thick. So what would it be like to stand on this world? You would not see a glittering, faceted surface like a giant gemstone in space. The reality would be far more alien and terrifying. The dayside would be a blinding, incandescent sea of molten rock and carbon, with diamond potentially floating on the surface of the lava like icebergs. The crushing gravity and searing heat would make it a landscape of utter devastation, a beautiful and brutal reminder that the universe can create wonders far beyond our imagination, forged in the most extreme of fires. That diamond world is forged in a star's violent embrace, but some cosmic structures reveal their mystery not in heat or light, but in silent, invisible radio waves. In 2020, astronomers mapping the sky with a powerful new radio telescope discovered something that should not have been there. Faint, ghostly circles glowing with radio energy appeared in their data. They were not stars, not galaxies, not the remnants of any known explosion. They were named odd radio circles, or ORCS, and they are so enormous that each one could easily swallow our entire Milky Way galaxy. The most baffling aspect of these circles is that they are completely invisible in every other wavelength of light. X-ray telescopes see nothing. Optical telescopes see only the ordinary galaxies that happen to lie in the same direction. These are ghosts in the radio spectrum, colossal, ring-shaped structures with no clear origin. They do not match the profile of any known object, from supernova remnants to the echoes of black hole mergers. They appear to be an entirely new class of astronomical entity, one that was completely unknown to science just a few years ago. The leading theories for what they could be are as strange as the objects themselves. One idea suggests they are the titanic shockwaves from a galactic merger on a scale we can barely comprehend. A collision of galaxies so powerful it sent a spherical tsunami of energy rippling out through intergalactic space for millions of years. Another, even more speculative hypothesis proposes they could be the throats of wormholes, the theoretical tunnels through space-time, with their immense gravitational fields energizing the gas around them to create these vast glowing rings. Yet neither theory is a perfect fit. If they are shock waves, what caused such a perfectly spherical and isolated explosion? If they are wormholes, why do we see them now and in such seemingly random locations? The discovery of the odd radio circles is a humbling reminder that our map of the cosmos is still profoundly incomplete. We have built telescopes powerful enough to see these structures, but we do not yet have the language to explain them. They are cryptic messages written in a dialect of physics we are only just beginning to learn. Even a star's final act can defy the script. In the year 1572, a new star blazed into view in the constellation Cassiopeia, shining so brightly it was visible in the daytime sky. This was Tycho's supernova, a titanic explosion that should have been the definitive end for a white dwarf star. These stellar cinders are the dense remains of sun-like stars, and when one steals enough matter from a companion, it crosses a critical threshold and detonates in a cataclysm known as a Type Ia supernova. For decades, astronomers were certain of one thing: this explosion was so violent, so complete, that it left nothing behind, utterly obliterating the star in a flash of cosmic light. But the universe had a surprise in store. When the remnant of Tycho's supernova was studied with modern X-ray telescopes, they found a ghost at the heart of the explosion. There, drifting within the expanding shell of stellar debris, was the surviving core of the white dwarf. It had been hurled away from the blast site at a tremendous speed, a burnt-out ember that refused to be extinguished. This was a zombie star, a stellar remnant that had somehow lived through its own death sentence. How is this even possible? The leading theory suggests a failed detonation. The supernova explosion may have begun as a flame near the star's center, but it fizzled as it raced outward. Instead of a single, symmetrical blast that shattered the entire star, the explosion might have been lopsided and incomplete. It was powerful enough to blow off the star's outer layers and create the magnificent remnant we see today, but not quite powerful enough to completely annihilate the incredibly dense core. The star was shattered, but a piece of it endured, kicked away by the uneven force of its own partial suicide. This discovery forces a profound revision of our stellar models. If one white dwarf can survive, how many others have? It suggests that stellar death is not a simple binary of survival or total destruction, but a spectrum with strange, intermediate states. The existence of zombie stars opens up a new class of celestial object, one that could potentially reignite or evolve in ways we have not yet begun to imagine. What other ghosts are hiding within the remnants of ancient explosions, waiting to be found? That zombie star survived its own cataclysm, but some cosmic motions suggest a force far greater than any stellar explosion. Across the universe, hundreds of galaxy clusters are caught in a mysterious current, all streaming in the same uniform direction at millions of miles per hour. This phenomenon is known as the dark flow. It is as if these immense structures, each containing thousands of galaxies, are being pulled by something colossal that lies beyond the edge of everything we can see. This is not the local pull of the Great Attractor or the Shapley supercluster. This is a motion on a cosmological scale, a current that seems to originate from outside our observable universe. The discovery came from studying the cosmic microwave background, the faint afterglow of the Big Bang. This primordial light carries a subtle imprint of its journey through space. As it passes through the hot gas of galaxy clusters, the cluster's motion creates a minute temperature shift in the light, a kind of Doppler effect. When scientists mapped these shifts, they found a startling pattern. The clusters were not moving randomly. They were all flowing in a coherent stream toward a specific point in the distant cosmos. The implications of this are staggering. The standard model of cosmology holds that the universe is largely uniform and that motions on such a vast scale should cancel each other out. The dark flow challenges that fundamental assumption. It suggests the gravitational influence of a structure so immense that it lies beyond our cosmic horizon. What could possibly exert such a pull? One controversial idea points to the multiverse. The theory suggests that our universe is just one bubble in a vast, frothing cosmic ocean of other universes. The dark flow could be the gravitational tug from a neighboring universe, an island of reality so close that its mass is drawing ours toward it. Other scientists propose that it is evidence of a pre-Big Bang structure, a relic from a time before time that still imprints its will on the cosmos. The debate is fierce, with some researchers arguing that the statistical evidence for the dark flow is not strong enough, or that it could be an artifact of incomplete data. Yet if it is real, the dark flow forces us to confront a humbling possibility. The greatest forces shaping our universe may not lie within the stars and galaxies we can see, but in the unimaginable vastness that exists just beyond the limits of our vision. The dark flow hints at forces beyond our universe, but a discovery within our cosmic neighborhood presents a problem of a different kind, one of profound absence. Drifting through space near the galaxy NGC 1052 is a ghostly island of stars so faint it was only recently catalogued. NGC 1052 DF2 is an ultra-diffuse galaxy, a wispy collection of stars you could almost see straight through. But its true weirdness is not in its appearance, it is in what it is missing. This galaxy appears to have no dark matter at all. For decades, astronomers have been convinced that dark matter, an invisible and mysterious substance that does not interact with light, is the cosmic glue holding galaxies together. Its gravitational pull is what keeps stars from flying apart as they whirl around a galaxy's center. We cannot see dark matter, but we can measure its gravitational influence by observing how fast stars are moving. The faster they orbit, the more mass, and therefore the more dark matter, must be present to keep the galaxy from tearing itself to pieces. When scientists measured the motions of 10 globular clusters, dense groups of stars, orbiting within NGC 1052 DF2, they expected to find the telltale signs of a massive dark matter halo. Instead, they found something that defied all expectations. The clusters were moving surprisingly slowly. Their speeds indicated that the total mass of the galaxy was almost exactly equal to the mass of its visible stars. There was no extra mass, no hidden gravitational anchor. The dark matter was simply gone. This is like watching a spinning carnival ride where the cars are whipping around at a dizzying speed, but the central structure is made of nothing but air. It should fly apart instantly. Yet this galaxy exists serene and intact. How can a galaxy hold itself together without its primary binding agent? One theory suggests it was born in a unique environment, perhaps formed from gas that was stripped away during a violent galactic interaction, leaving it starved of dark matter from the very beginning. Another, more radical idea is that our understanding of gravity itself is flawed. The theory of modified Newtonian dynamics, or MUND, proposes that gravity behaves differently at extremely low accelerations, like those found in the outer reaches of galaxies. In this view, dark matter is an illusion, a mathematical fix for a law of physics we do not fully understand. The existence of a galaxy with no dark matter is a direct challenge to MUND, which predicts that such an object should not be possible. So this impossible galaxy does not just question one component of our cosmic models. It forces a confrontation between two competing worldviews. Is the universe filled with an invisible substance we cannot detect, or are the laws of gravity themselves not as universal as we once believed? This faint, see-through smudge of stars has become the center of a debate that could rewrite the rules of the cosmos. A faint, ancient sun drifts just 200 light-years away, a relic from the dawn of time that nearly broke our understanding of the cosmos. This is the Methuselah star, catalogued as HD 140283, a star whose initial calculated age was older than the universe itself. Its estimated age came in at a staggering 14.5 billion years. A number that directly contradicted the universe's own age of 13.8 billion years. It was a paradox that sent shockwaves through the world of cosmology. How could a star exist before the reality that birthed it? The answer lies in the delicate art of stellar archaeology. To date a star this ancient, astronomers measure its abundance of certain elements. The very first stars were composed almost entirely of hydrogen and helium forged in the Big Bang. When those pioneers exploded as supernova, they seeded the cosmos with heavier elements like iron. The Methuselah star has an extremely low metallicity, meaning it contains very little iron, marking it as a second-generation star, one of the very first to form. By pinpointing its position on a stellar evolution chart and modeling how it burns its fuel, scientists can estimate its age with remarkable precision. Yet, that precision initially created an impossible timeline. The solution to the paradox came from refining our measurements of both the star and the cosmos. More precise data from the Gaia spacecraft provided a better estimate of the star's distance and intrinsic brightness, crucial factors in the age calculation. At the same time, observations from the Planck telescope refined the universe's age to its current value of 13.8 billion years. The revised age for the Methuselah star now sits at around 14.46 billion years, but with a margin of error of plus or minus 800 million years. This means its most likely age falls just within the lifetime of the universe, but its upper limit still brushes against that impossible pre-existing era. This star remains a profound outlier, a stubborn piece of data that refuses to fit perfectly into our cosmic timeline. Its continued presence challenges us to measure with even greater care, reminding us that the oldest witnesses to creation still have secrets they are reluctant to surrender. Those ancient stars challenge our cosmic timeline, but a more recent discovery reveals a hidden structure of staggering proportions right here in our own galaxy. Emanating from the very heart of the Milky Way are two colossal orbs of energy, towering above and below the galactic plane like ghostly cosmic lungs. These are the Fermi bubbles, vast structures that glow with high-energy gamma radiation, completely invisible to our eyes but dominating the galactic center. Each bubble stretches for 25,000 light-years from end to end. If they were visible in our night sky, they would span an angle larger than 50 full moons. Their discovery was a complete surprise, announced in 2010 after scientists painstakingly analyzed data from the Fermi Gamma Ray Space Telescope. For the first time, we saw that our galaxy is not a simple, flat disk of stars, but is crowned by these immense hourglass-shaped lobes of pure power. The question that immediately confronted astronomers was a simple and profound one. What event could possibly have blown these bubbles? What kind of cosmic engine has the force to inflate structures of this scale? The leading suspect is our own supermassive black hole, Sagittarius, a star. While it is quiet today, it may have had a violent past. A tremendous eruption, perhaps occurring a few million years ago, could have shot out colossal jets of matter and energy from the black hole's poles. This outburst would have punched through the galaxy's gas, inflating these bubbles and filling them with fast-moving particles that now glow in gamma rays. An alternate theory suggests a different kind of frenzy. It is possible that the center of our galaxy experienced a period of intense star formation, a starburst that created thousands of massive stars in a short period. These stars would have lived fast, died young, and exploded as supernova in a coordinated chain reaction. The combined force of all these explosions could have blown a giant, superheated wind straight out of the galactic disk, carving out the bubbles we see today. Both theories have their merits and their flaws, and the true origin remains one of the most active debates in galactic astronomy. The Fermi bubbles stand as a silent, invisible monument to a cataclysmic event in our galaxy's history, a reminder that even our own cosmic home has undergone violent and dramatic transformations that are only now coming to light. A lone fugitive is racing through the galaxy at an almost unbelievable speed. Zeta Ophiuchi is a stellar behemoth, a blue giant 20 times more massive than our Sun, and it is not wandering idly. It is fleeing, hurtling through space at nearly 66,000 miles per hour. Its journey creates a spectacle of pure cosmic force, as this runaway star plows through the dense clouds of interstellar gas and dust. It cannot move quietly. The star's powerful stellar wind, a constant stream of charged particles, slams into the material ahead of it. The result is a brilliant, glowing wall of compressed and superheated matter that wraps around the star in a vast, horseshoe-shaped wave. This is a bow shock, the stellar equivalent of the wave that forms at the prow of a speeding ship. In visible light, it appears as a delicate, rippling curtain of red and orange, a beautiful and violent announcement of the star's passage. But how did this star become a cosmic cannonball? The most compelling theory is a story of stellar betrayal and a cataclysmic divorce. Astronomers suspect Zeta Ophiuchi was not always alone. It was likely once the smaller partner in a binary dance with a far more massive star. That companion lived a fast and furious life, burning through its nuclear fuel in just a few million years. When it could no longer support itself, its core collapsed and it detonated as a supernova. This explosion would have been asymmetrical, violently ejecting the remains of the dead star in one direction, and in a titanic act of recoil, flinging Zeta Ophiuchi away at its tremendous speed like a stone from a sling. Suddenly freed from its gravitational bond, the surviving star was set on its solitary, high-velocity path across the galaxy. We are essentially seeing the aftermath of a stellar murder, with one star obliterated and its partner sent careening into the void. The magnificent bow shock is the lasting scar of that ancient, violent event, a ghostly imprint of a partnership that ended in a blaze of cosmic fire. What other runaway stars are silently carving their paths through the dark, carrying with them the secrets of their violent origins? While runaway stars carve their paths through the galaxy, a different kind of precision endures on a world far beyond our own. At the North Pole of Saturn, a perfect geometric storm has raged for decades. This is no ordinary hurricane, but a colossal, six-sided jet stream, a hexagon of clouds so vast it could swallow 4 Earths whole. Its sides are razor-sharp, each one stretching over 8,000 miles, and at its center spins a perpetual vortex, a silent eye in a storm of impossible geometry. This hexagon is not a fleeting atmospheric quirk. It was first glimpsed by the Voyager probes in the 1980s and has been monitored ever since by the Cassini spacecraft, persisting through decades of Saturn's chaotic, turbulent weather. The planet's winds scream at over 300 miles per hour, yet this six-sided structure remains locked in place, unyielding and stable. How can such a perfect polygon form and endure in a fluid, gaseous environment where chaos should reign? Scientists believe the answer lies in the deep layers of Saturn's atmosphere. They theorize that the hexagon is a standing wave, a pattern created by differences in the speed of atmospheric currents at various latitudes. Think of it like a spinning coffee cup. If you stir the liquid inside at just the right speed, you can create stable, oscillating patterns on the surface. Saturn's atmosphere may be acting on a planetary scale, with deep-rooted jet streams shearing against each other to produce this six-sided oscillation. To test this, researchers have created laboratory experiments using tanks of spinning water, successfully generating polygonal shapes, including hexagons, by controlling the fluid's rotation and speed. These models suggest that the hexagon is a towering structure, a stack of waves that extends hundreds of miles deep into the planet's weather layer. Yet, the exact recipe of wind speeds, densities, and planetary rotation that creates a hexagon, and not a pentagon or an octagon, remains one of atmospheric science's most elegant puzzles. It is a natural badge of order pinned to a gas giant, a reminder that even in the most violent and dynamic places, the universe has a hidden fondness for geometry. That geometric storm on Saturn is a marvel of atmospheric order, but deep within our galaxy, a different kind of star is engaging in a strange, secretive ritual. They are called the Old Smokers, ancient red giants that appear to spend decades, even years, in a state of near hibernation before suddenly exhaling colossal clouds of dark, obscuring dust. For long periods, these stars seem perfectly normal, glowing with a steady, elderly red light. Then, without clear warning, they begin to fade, dimming dramatically as they cloak themselves in a shroud of their own making. They are not erupting or exploding, they are smoking, billowing out immense quantities of sooty particles that hide them from view. This bizarre behavior was only recently recognized as a distinct and crucial phase of stellar life, a final, slow-motion cough from aging suns. Astronomers now suspect this is a common but previously overlooked stage for stars like our own Sun, a last act before they shed their outer layers completely to form beautiful planetary nebulae. During this smoky phase, the star is effectively redistributing its own substance back into the cosmos. The dust clouds it releases are rich with complex elements forged in its core over billions of years, elements like carbon, silicon, and iron. These are the very building blocks of rocky planets and ultimately life itself. The Old Smokers, therefore, are not just celestial curiosities, they are cosmic gardeners. By releasing these enriched clouds slowly and steadily, Rather than in a single violent explosion, they may be seeding their local regions of the galaxy with the raw materials for new worlds. This gentle, cyclical process could be a fundamental mechanism for recycling the elements of life across space and time. How many of these quiet, aging giants are hidden in plain sight, patiently contributing to the galaxy's chemical richness with every dark, smoky breath they take? Those old, smoky stars are slowly seeding the galaxy with the stuff of worlds, but another stellar death has created a place of ultimate cold. Drifting 5,000 light-years away, the Boomerang Nebula holds a chilling record. It is the coldest known place in the natural universe, a cosmic freezer where the temperature plummets to just 1 degree above absolute zero. That is even colder than the faint, pervasive background glow left over from the Big Bang itself. This nebula is the final, frigid breath of a star very much like our own Sun. As it reaches the end of its life, the star at its core is shedding its outer layers at a ferocious speed. It is ejecting mass at a rate 100 billion times faster than our Sun's solar wind. This incredible velocity is the key to the profound cold. The physics at work here is a phenomenon you experience every time you use a spray can. When a gas expands very rapidly, it cools down. This is called adiabatic cooling. You feel this when a deodorant spray feels cold on your skin. The propellant gas expands quickly as it leaves the can, stealing heat from its surroundings. Now imagine that process on a cosmic scale. The gas from the dying star is billowing outward so fast that it expands and cools to a temperature barely above the theoretical point where all atomic motion would cease. This is the ultimate fate that awaits most Sun-like stars, a transformation into a beautiful but temporary planetary nebula. The Boomerang is in this brief phase, a fleeting structure that will eventually dissipate into the void, leaving behind only the star's exposed white dwarf core. This cosmic chill offers a profound glimpse into the final stages of stellar life, a reminder that the end of a star is not always a blaze of heat, but can also be a silent, accelerating rush into the deepest cold the universe can provide. The deepest cold of the Boomerang Nebula emerges from physics we can almost grasp, but some corners of theoretical physics propose forces and substances that defy our very definitions of matter. One of the most mind-bending ideas comes from physicist Howard Georgi, who suggested the existence of an entirely hidden sector of reality. This is the concept of the unparticle. Imagine a substance that does not behave like particles at all. It would not have a definite mass or a specific size. Instead, unparticled stuff would be scale invariant. This means it would look exactly the same whether you were observing it from the perspective of a single atom or an entire galaxy. A chunk of unparticled material would have no characteristic scale, no inherent graininess. It would be a smooth, continuous presence that interacts with our familiar world of protons and electrons only through the feeblest of whispers, the force of gravity. How could we ever hope to detect such a phantom? The search is one of pure speculative ingenuity. If unparticles exist, their subtle influence might slightly alter the behavior of known particles in high-energy collisions. The next generation of particle colliders might find that certain collisions produce particles that fly away with missing energy, energy that has been carried off by an invisible, unparticled medium. Astronomers, too, have a role to play. They could scrutinize the delicate rotations of distant neutron stars, looking for tiny, unexplained wobbles induced by the gravitational pull of a diffuse unparticled cloud. They might even analyze the precise properties of the cosmic microwave background, the oldest light in the universe, for any anomalous imprints that this scale-invariant stuff might have left behind. While entirely hypothetical, the unparticle represents a thrilling frontier of thought. It challenges us to consider that the true composition of the cosmos may not be a collection of tiny billiard balls, but something far more fluid, strange, and seamlessly woven into the fabric of space itself. Looming in the distant cosmos are structures so immense they defy our very definition of an object. Known as Lyman alpha blobs, these are colossal clouds of pristine hydrogen gas, some of the largest single entities in the entire universe. The most famous of these, Lyman alpha blob 1, is a vast diffuse glow spanning hundreds of thousands of light years, a single cloud that could easily swallow thousands of galaxies like our own. But its sheer size is not its greatest mystery. These blobs should be dark and invisible, cold clouds of simple gas drifting in the void. Instead, they shine with an intense and specific crimson light, the telltale signature of hydrogen gas emitting what is known as Lyman alpha radiation. The central puzzle is what provides the energy to make these gargantuan clouds glow so brightly. One leading theory suggests they are cosmic cradles on an unimaginable scale, regions of frenzied star formation where millions of new suns are igniting at once. The combined ultraviolet light from all these newborn stars could be exciting the surrounding hydrogen, causing the entire cloud to fluoresce like a neon sign. Another possibility points to a monstrous engine at the blob's heart. An active galactic nucleus, a supermassive black hole greedily feeding on matter, could be pouring out so much energy that it lights up the entire gaseous structure from within. There is even a more subtle hypothesis, a process called gravitational cooling. As gas slowly, inexorably falls into the blob's own immense gravitational field, it gains energy and heats up, and as it cools back down, it releases that energy as the faint, pervasive glow we detect. The true answer might be a combination of all three, a cosmic collaboration between star birth, black hole activity, and the simple, relentless pull of gravity. These blobs are not merely objects, they are the raw potential of the universe made visible, the primordial gas from which entire galactic empires will one day rise, caught in a moment of brilliant, unexplained illumination. This nebula appears as a delicate, symmetrical sculpture of glowing gas, an ethereal sphere encircled by two majestic wings, known as the Dragon's Egg, or NGC 6164 and 6165. It is the beautiful and violent creation of a truly bizarre star. At its heart lies a rare magnetic monster, a star of the O-type class designated HD 148937. This is not a gentle giant, it is a seething, turbulent ball of plasma with a magnetic field 100 times stronger than any other star of its kind. This immense magnetic force channels the star's own fury, shaping its powerful stellar wind. Instead of blowing in all directions evenly, the wind is funneled by the magnetic field lines streaming outward from the star's poles at tremendous speeds. This dual-lobed outflow acts like a cosmic sculptor's tool, carving into the surrounding cloud of gas and dust that the star itself ejected earlier in its life. The result is a bipolar nebula, a structure with two nearly identical lobes that stretch outwards, giving it the appearance of a cosmic butterfly or a brilliant egg cradled within a pair of ethereal wings. The star's unique properties are a direct challenge to our understanding of how massive stars live and die. It is far hotter, brighter, and more massive than our Sun, and its intense magnetism is an anomaly that theorists struggle to explain. Such powerful magnetic fields are thought to be remnants from the star's formation, frozen into its core during its chaotic birth. But maintaining a field this strong throughout the star's violent life defies current models. The Dragon's Egg offers a glimpse into a rare and extreme evolutionary path, a pathway where magnetism dominates, sculpting not only the star's immediate environment but potentially the very nature of its eventual death. How many other magnetic maestros are out there, quietly choreographing the gas and dust around them into beautiful, symmetrical forms we have yet to discover? Drifting in the emptiness far beyond its sun, a lonely giant defies every rule of planetary birth. HD 106906b is a planet that should not exist, a colossal world 11 times more massive than Jupiter, orbiting at a distance so vast it redefines the word remote. This gas giant circles its host stars at 730 times the distance from the Earth to our Sun. At such an extreme separation, a single orbit takes this world 15,000 years to complete. How can a gas giant of this size form in a region of space so empty and cold? Our standard models of planet formation tell a clear story. Gas giants like Jupiter are thought to be born close to their stars within a swirling disk of gas and dust. In this dense, warm environment, a rocky core can form quickly, growing massive enough to attract a vast envelope of hydrogen and helium gas. But out where HD 106906b lies, the protoplanetary disk would have been incredibly thin and sparse. Material is so scarce that a planetary core could not form fast enough to capture gas before the disk itself dissipated into space. It is like trying to build a snowman during a light flurry. You simply cannot gather enough material before the weather changes. So how did this planetary orphan come to be? One radical theory suggests it did not form like a planet at all, but like a star. In the chaotic early days of the system, a gravitational instability could have caused a portion of the disk to collapse directly under its own weight, spontaneously birthing a gas giant without the need for a rocky core. This process, called disk instability, is a stellar formation mechanism in miniature. Yet even this exotic idea struggles to explain the planet's current lonely orbit. Its path is not only distant but also tilted, wildly misaligned with the inner solar system's debris disk. This points toward a violent past, a gravitational struggle that catapulted the young planet outward. Perhaps it was born much closer to its suns and had a close encounter with another giant, a gravitational slingshot that sent it careening to the frozen outskirts of its stellar domain. HD 106906b stands as a stark challenge, a solitary sentinel in the deep freeze that forces us to question whether our solar system's calm and orderly formation is the rule or a cosmic exception. What other impossible worlds are waiting in the dark, their very existence a challenge to our textbooks? The violent histories of galaxies are often written in their very shapes, and one of the most striking examples bears the unmistakable silhouette of a classic video game foe. The galaxy NGC 1316 stares out from the cosmos with the same iconic profile as a space invader, a cosmic apparition born not from code but from a cataclysmic collision. This is no simple, stately spiral. Its structure is a complex and disturbed tapestry of ghostly shells, vast dust lanes, and sweeping rivers of stars that have been torn from their original orbits. Its entire appearance is a testament to a violent past, a galactic merger that occurred billions of years ago. When two galaxies of unequal size slammed together, their delicate structures were irrevocably shredded. The gravitational chaos did not just destroy, it also created, compressing vast reservoirs of gas and triggering a firestorm of new star formation. The resulting galaxy is a colossal elliptical, but one riddled with the scars of its birth. Those dark, intricate dust lanes are the mangled remains of the smaller spiral galaxy that was consumed, now wrapped like a shroud around the victor. The faint, nested shells of stars that surround it are the gravitational echoes of the merger, ripples in a stellar pond that have been frozen in time. This cosmic invader is not just a static monument to destruction. It is an ongoing engine of stellar rebirth, a place where the violent death of two separate galactic identities has given rise to a new, more massive and intensely active entity. It serves as a powerful reminder that the serene galaxies we see in textbooks are often the tranquil aftermath of ancient wars, their beautiful shapes forged in the chaotic fires of collision. These cosmic heartbeats pulse across the galaxy, a rhythmic throb of light from stars locked in an intimate gravitational dance. Known as heartbeat stars, these binary pairs follow such elongated, egg-shaped orbits that their mutual pull becomes a dramatic physical force. When they swing close together, their gravitational embrace stretches each star into a teardrop shape. This tidal distortion is so extreme that it brightens their combined light, creating a sharp peak in their light curve that looks exactly like a spike on an electrocardiogram. Then, as they swing apart to the far ends of their orbits, they relax back into spheres and their light dims. This is not merely an eclipse, it is a literal pulsing of the stars themselves, a periodic brightening and dimming caused by their changing shapes. The dance goes even deeper than their surfaces. The intense and rhythmic gravitational pull triggers seismic activity within the stars, setting off immense starquakes that ripple through their interiors. These quakes are like ringing a bell, sending vibrations through the stellar plasma that astronomers can detect as subtle flickers in the light. By studying these stellar oscillations, scientists can perform a kind of cosmic ultrasound, peering into the hearts of stars to understand their internal structure, density, and composition. Heartbeat stars are natural laboratories for studying the most extreme effects of gravity, revealing how this fundamental force can physically sculpt and resonate with entire suns. What other secrets about the inner lives of stars are being broadcast in these rhythmic pulses, waiting for us to learn their language? Those rhythmic heartbeats of distant stars reveal the intimate forces shaping suns, but here in our own galactic neighborhood, a different kind of stellar whisper is rewriting the story of our cosmic home. Orbiting the Milky Way and Andromeda are galaxies so faint and ghostly they were hiding in plain sight for decades. These are the ultra-diffuse galaxies, vast collections of stars stretched so thin they are almost transparent. Antlia 2 is one of these phantoms. It is a galaxy the size of the Large Magellanic Cloud, one of our most prominent satellite galaxies, but it contains only a fraction of the stars. If you were standing on a planet inside Antlia 2, your night sky would be almost empty, a stark contrast to our own star-filled vista. The sheer faintness of these objects makes them incredibly difficult to detect, like trying to spot a single, dim light bulb floating in the middle of the ocean. Their existence alone is puzzling, but their true mystery lies in their relationship with dark matter. According to our standard models, a galaxy as large as Antlia 2 should be anchored by an immense, heavy halo of dark matter. This invisible gravitational glue is what prevents galaxies from being torn apart by their own rotation. Yet when astronomers measured the motions of stars within Antlia 2, they found something baffling. The stars were moving so slowly that the galaxy's total mass was shockingly low. It appears to have almost no dark matter at all, making it incredibly fluffy and vulnerable. How can something so large and diffuse hold itself together? The puzzle deepens with other ultra-diffuse galaxies that show the exact opposite behavior. Some of these faint smudges seem to be dominated by dark matter, containing far more of the invisible substance than their meager starlight would suggest. They are like massive, invisible giants wearing only a faint cloak of stars. This stark contradiction is forcing a major rethink. Are we seeing the results of wildly different formation histories? Could intense supernova explosions in the early universe have blown away the gas and dark matter from galaxies like Antlia 2, leaving them as pale, puffed-up ghosts? Or does their very existence point to a flaw in our understanding of how gravity works on the largest scales? These lost galaxies of the local group are not mere curiosities. They are cosmic experiments testing the very rules we believe govern the universe from our own backyard. Its intense blue glow makes the blue snowball nebula look like a single, perfect jewel in the telescope's eye. Yet a closer look reveals this is no simple sphere. Known as NGC 7662, it is a planetary nebula, the final, beautiful sigh of a dying star. At its heart, a searing hot white dwarf, the burnt-out core of the star, floods the surrounding space with ultraviolet radiation. This energy ignites the shells of gas the star gently pushed away over thousands of years, making them fluoresce with an unearthly light. The nebula's structure is a complex, layered onion, with different chemical elements glowing in their own distinct colors. The brilliant blue comes from energized oxygen atoms, while hints of red and green trace regions rich in hydrogen and nitrogen. Each hue is a chemical fingerprint, a ghostly map of the star's own internal fusion processes, now painted across light years of space. This entire, breathtaking display is tragically brief. The glowing shells will expand and dissipate into the interstellar void within just a few tens of thousands of years, a fleeting moment on the cosmic clock. The white dwarf will slowly cool for trillions of years, fading into a cold, dark cinder. But in that brief, brilliant phase, the star performs its most vital act of cosmic recycling. The very elements forged in its core and expelled in its death throws the carbon, oxygen, and nitrogen now glowing so brightly, will one day be swept up into new clouds of gas and dust. These are the raw materials for future stars, planets, and perhaps one day life itself. The blue snowball is not merely a tombstone, it is a glittering, temporary nursery, ensuring that the end of one star is just the beginning of countless new stories. The brilliant, transient beauty of a planetary nebula gives way to a far more enduring and ghostly structure. Mira, a pulsating red giant in the constellation Cetus, has been watched by astronomers for centuries as its brightness waxes and wanes over an 11-month cycle. But its true secret was only revealed when we looked beyond the visible spectrum. Stretching across an almost unbelievable 13 light-years of space, this star drags behind it a colossal, comet-like tail, a shimmering wake of gas and dust that is utterly invisible to our eyes. This is not a gentle trail of starlight, but a cosmic scar, the evidence of a star's high-speed journey through the galaxy. Mira is a runaway, hurtling through the interstellar medium at over 290,000 miles per hour. As it travels, it continuously sheds its outer layers, a slow and steady bleed of material into space. This ejected gas does not simply drift away. Instead, it slams into the thin, invisible medium of hydrogen and other particles that fills the void between stars. The resulting friction heats the gas, causing it to glow with an intense ultraviolet light which our telescopes can detect. This process carves out a vast, streamlined tail, much like the wake of a speedboat cutting through calm water. The sheer length of this structure is what defies belief. 13 light-years is a distance so vast it would take a beam of light, the fastest thing in the universe, 13 years to travel from one end to the other. Within that incredible span, the tail contains a rich chemical soup, including oxygen, carbon, and even the building blocks for water. Mira is not just a variable star, it is a celestial gardener on an epic scale, seeding a vast corridor of space with the elements necessary for future planets and perhaps even life, all while painting its own breathtaking, invisible signature across the heavens. There is a hidden city inside the pillars of creation. The iconic photograph from the Hubble Space Telescope shows 3 towering spires of cosmic dust and gas, a majestic and ghostly landscape silhouetted against a starry backdrop. But that breathtaking visible light view is only a surface glimpse, a portrait of the outer walls. When we switch our vision to the infrared spectrum, the entire scene transforms. The obscuring clouds of dust which block visible light so effectively become almost transparent to the longer wavelengths of infrared light. It is like lifting a veil, revealing the vibrant, hidden life teeming within these colossal structures. Suddenly, the dark, brooding pillars are filled with a multitude of brilliant points of light. These are the infant stars that were always there, hidden deep inside their dusty cradles. The pillars themselves, so solid and imposing in the Hubble image, now appear as wispy, ethereal skeletons, backlit by the intense glow of the newborn suns they are struggling to contain. This dramatic shift in perspective reveals the true, dynamic nature of this stellar nursery. The visible light shows us the beautiful, cold exterior, the raw material of star birth. The infrared view shows us the hot, energetic results, the stars themselves, blazing forth and preparing to eventually destroy the very pillars that gave them life. How many other cosmic vistas are hiding entire worlds of activity, simply waiting for us to look at them in the right kind of light? And so we arrive at the final oddity, an object that was both a visitor and a ghost. In 2017, our solar system was briefly graced by a traveler from another star. It was the first of its kind ever seen, a dark, reddish object hurtling past the sun at breakneck speed. Astronomers named it Oumuamua, a Hawaiian word meaning scout from the distant past. Its initial detection was bizarre enough, but the closer we looked, the stranger it became. First, there was its shape. Based on the way its light changed as it tumbled through space, scientists deduced Oumuamua was not round, not lumpy, but profoundly elongated. It was shaped like a giant cosmic cigar or a pancake, with its length estimated to be up to 10 times greater than its width. This was unlike any asteroid or comet we had ever seen in our own solar system. The second and far more perplexing mystery was its motion. As Oumuamua sped away from the sun, it accelerated in a way that could not be explained by gravity alone. Something was giving it an extra push. With comets, this is a common effect. Ices on the surface heat up, turn to gas, and jet away like a rocket engine, propelling the comet forward. But when telescopes pointed at Oumuamua, they saw no coma, no tail, no cloud of gas or dust that would explain this non-gravitational acceleration. It was as if a silent, invisible engine was at work. The debates ignited immediately. Was it a comet after all, but one with a very unusual composition that produced gas we could not detect? Was it a porous, fractal-like object, a cosmic dust bunny whose low density allowed sunlight itself to push it along? Or, as one prominent scientist controversially suggested, could it have been an artifact of an alien civilization, a light sail, or a derelict probe? The most likely explanation remains a natural one. Some models suggest it was a water ice iceberg with a hardened, carbon-rich crust that hid its outgassing. Others propose it was a shard from a Pluto-like world that was torn apart by its home star long ago. Yet the truth is, we do not know for certain because Oumuamua is now gone, speeding back into the interstellar dark, its secrets forever locked away. Its fleeting visit, however, has fundamentally changed our approach to astronomy. We are now actively scanning the skies for the next interstellar scout, and missions are already being planned, ready to launch at a moment's notice to intercept and study the next visitor. Oumuamua was a brief, silent messenger, a reminder that the greatest cosmic oddities are not always in the distant void, but can pass right through our own celestial backyard, challenging everything we think we know. From the silent, geometric perfection of the Red Rectangle to the fleeting, enigmatic passage of Oumuamua, this journey through 30 cosmic oddities reveals a universe that thrives on the bizarre. Each of these phenomena, from the zombie star that survived its own death to the galaxy with no dark matter, is a crack in the facade of our understanding. They are not mere footnotes in astronomy, they are fundamental challenges, forcing us to rewrite our textbooks and reconsider our place in the cosmos. The true engine of discovery in astronomy is not the confirmation of what we already know, but the thrilling confrontation with what we do not. These mysteries are not roadblocks, they are invitations, beckoning us to look deeper, think stranger, and question everything. So the next time you find yourself under a clear night sky, remember the incredible weirdness hiding within its apparent tranquility. Remember the runaway stars, the hexagonal storms, and the ghostly whispers from the void. Let that sense of wonder pull you closer. Which of these oddities reshaped your view of the universe the most? Share your favorite in the comments below. And if you are hungry for more journeys to the edge of understanding, subscribe so we can continue exploring the cosmos's deepest secrets together.